Howdy, my name is Reid, and for the DEEP program, my project is a Lidar scanner.
Of Lidar is relatively straightforward. We really only have two primary components. We have a laser and we have a sensor. The laser emits a laser in the near infrared range, which then bounces off of a target object and scatters. Some of this light bounces back to the sensor, which is then used to calculate the distance through a simple formula. The total time it takes the laser to go from the emitter to the sensor and bounce off the object is then multiplied by the speed of light and then divided by 2. In general terms, calculating the distance from the laser to the object.
And for how the demo actually works, we have an Arduino microcontroller that's attached to two servo motors and a Lidar scanner. And so we can see that we have an X and a Y axis. So the X axis will take one sweep across the field of plane, or the field of view, and then it'll take one step up in the Y, and it'll continue that until it goes to about 45 degrees in both directions. Once that's done, it'll send the output from the Lidar scanner to the software component, which will then output the final visualization.
The time lapse shown below shows the LiDAR scanner moving across the field of view and scanning an object relatively close to it to the left of the field of view. We can see that the more redshifted it is, the closer it is as a way of representing the distance or the physical distance between the LiDAR scanner and the object. And we can see that the more green and blue shifted it is on the spectrum, the further away it is, i.e. a wall behind the closer object. There's a smoothing algorithm that was implemented as a way to smooth the edges, but because of hardware limitations, some of the resolution is lost when the scanner completes its cycle. We have seen how LiDAR works and we've seen an example of it, but how is it actually used in real life? And there's a couple of key areas in which it's used very prominently. Most notably, it's used in ecology, where mapping out riverbeds or forests is very, very beneficial to monitor things like climate change. It's used in self-driving cars or self-driving technology pretty ubiquitously as a way for cars to, in a way, sense where they are instead of seeing like normal cameras would allow them to do. And finally, it's used in construction where mapping out a physical space or having a 3D representation of a physical space is very beneficial for planning and for further needs in construction.
This is just a simple demo for how LiDAR technology can be used for applications in imaging and how it can be used in our everyday lives.